Hello, my name is Amos Tarfa, or Amos the Math Guy. Today, I want to just say thank you to all my teachers, especially Mr. Waziri, who you'll be seeing in the video that starts here shortly. I could go down the list thanking every one of my teachers, and I'm grateful, and I will do that by God's grace. As time goes on, I'm going to just go back to primary one, primary two, primary three, and so on and so forth. But today, I'm a medical physicist. I work with X-rays, and I work with different things with MRI, CT, and I also teach mathematics. But one of the things that has influenced my world is my understanding of chemistry and physics. And from the chemical side or the chemistry side, there's a branch of chemistry that is called physical chemistry. And within physical chemistry, you understand the atomic structure. Mr. Waziri is going to present us with a brief history of the atomic structure. My goal is really to just find ways to encourage our teachers that really played a huge role in our lives. Let's give them maybe some opportunities to share some of their knowledge in video formats that we can then share with the upcoming generation of scientists. So I'm really grateful to Mr. Waziri for what he has done in encouraging us to study chemistry well. And I want to present you with the history of the atom, the different models. Mr. Waziri will take it from here, recording from Abuja, Nigeria. Thank you so much again, Mr. Waziri. Have a blessed day.
Good morning, students. Today's topic is atomic structure. We cannot talk about the atomic structure without stressing that the atom was discovered and so many work was done on the atom by so many scientists. The atom is looked at as the smallest particle of matter. The atom is an important world particle because it is the building block of all matter. Matter, as you all know, is everything that exists in this universe, in any state, in any form, things you can feel, things you can see, things you can touch, all makes up matter. Atom was first defined theoretically by a philosopher called Democritus. He defined an atom as the smallest particle of matter that is indivisible. This theoretical presentation by Democritus was later modified by scientists. But I want to inform you that the Dalton's atomic theory of 1803 gave the way for more work to be done in elucidating the actual structure of the atom. First to start was J.J. Thomson, who discovered the electrons. Upon discovering the electrons, J.J. Thomson proposed that an atom is spherically shaped with electrons embedded, and the positive protons are scattered and mixed up with the electrons, giving it an equal number of distribution. He then proposed what was called the plum pudding model of the atom in 1904. And according to his model of the atom, which is spherical, consists of protons and electrons all put together, just as you have plums in puddings. The Thomson model of the atom did not last long because it could not explain some chemical processes. Then came the Rutherford's model of the atom. Rutherford, after carrying out his famous alpha particle experiment using a gold foil, discovered that contrary to Thomson's model, the protons are not distributed together with the electrons equally. He discovered from his experiment that the protons are concentrated at the center of the atom called the nucleus, and that the electrons revolve around the nucleus in orbits, just as the planets revolve around the sun. And that gave rise to Rutherford's model of the atom called the planetary model. Unfortunately too, the Rutherford's model was modified by Niels Bohr after a series of work by Niels Bohr and other scientists. The Niels Bohr model agreed with the Rutherford's model of a central nucleus, but disagreed with electrons revolving around the nucleus in circular orbits. Niels Bohr proposed that the electrons actually exist around the nucleus, but they exist in what are called energy levels, and that these electrons, of course, do move, but they can move up and down from one energy level to another, depending on the situation. Again, as work went on, it was discovered that the Niels Bohr model was able to explain many chemical properties, but could not explain much. Specifically, the Niels Bohr model was able to explain spectral lines. After the Niels Bohr atom came the wave-particle model of the atom. In the wave-particle model of the atom, the electrons were not considered as particles only. They were considered to have a dual nature of both particle and wave. That means, at one time, the electrons can be considered as particulate. At another time, they can be considered as waves. This wave-particle model of the atom was accepted because it could explain so many concepts of chemistry and science. Today, we hold on to the wave-particle nature of the matter, wave-particle nature of the atom. But you know, science continues to be modified through research work. I want to inform you that there were so many other scientists that also worked in elucidating the structure of the atom. We have people like James Chadwick, we have de Broglie, we have Heisenberg, we have Maria Curie, and so many others. Thank you.